In the previous video, we talked about how to set up the null hypothesis and alternative hypothesis, and how to tell if your test is going to be a left tail test, a right tail test, or the two tail test. We also talked about critical values, that we're going to use a normal z distribution for proportions. We're going to use t-distribution for test of means, and we're going to use a chi-square distribution for the test of variance. Now, one thing that I want to mention here is, okay, we figured out which distribution we're going to use, but what are those critical regions? Where are they coming from? Well, they're coming from the significance level, or your alpha level. So basically, your alpha level tells you what you will consider an unusual value. Okay, because remember, way back in probably unit 3, we were talking about empirical rule, and we said that everything more than 2 standard deviations away from the mean is gonna be unusual value. And then in unit 10, we said we tuned in this idea a little bit, and we said, okay, we're gonna specify unusual values a little bit more. We're gonna say it depends on how confident you want to be in your results. Like if you want to be at 99% confident, then 1% values are going to be unusual. If you want to be like 95% confident, then 5% values are going to be unusual. So this is going to play here as well. So if they tell you that the confidence level is 95%, for example, that would mean if so the CI confidence level is 95%, that will tell you that alpha is 0.05, right? And that's what your critical region is going to be. So the size of this region is 0.05. So you're going to go to your chi-square distribution and find the chi-square value that separates the top 5% of the values, and that's going to be your critical value for this test. Okay, and the critical region is 5% because the confidence level was 95%. Okay, so now that's what's similar with unit 10. What's different from unit 10 is that, remember, in unit 10, you always split your alpha in 2 tails. So, and that's gonna still be the same if we're talking about the two-tailed test. So in two-tailed test, the alpha will be split, and you're gonna have 0.025 on one side and 0.025 on the other side, and you're gonna have two critical values and two critical regions as well. Now, for a right tail test and left tail test, your entire alpha is going to be on one side, and you're going to have one critical region and one critical value. So keep that in mind. All right, let's continue, and let's look at how we assess the evidence. So in this step, you're going to answer the question, is the sample statistic unusual? And there are 2 ways to assess how unusual the sample result is. First, let's remember that our initial assumption is the truth of the null statement concerning the population. All right, so the initial assumption is the truth of the null statement concerning the population. So given this assumption, the two methods are estimating the probability value of obtaining the test statistic by chance. That's the first method. We are looking at the test statistic and seeing what's if the null statement is true, what's the chance that we got what we got? Was there a high chance that we would get that, or is it a rare event? So we're going to assess that. So that's the first method is looking at a probability value. So estimating the probability value, which translates into finding the p-value. P-value is short for probability value, and compare against the alpha region. Remember our significance level. So if we're 95% confidence, want to be 95% confident in our result, for example, then the alpha region would be 0.05. So we find the probability value and we're going to compare against the alpha region. So the method number 2, checking if the result falls within the critical region. So basically looking at a relative standing of our result. So where is it located compared to the null statement, compared to the null hypotheses? Is it did it land in the tails? Did it land far away from the claimed mean? Is it unusually high? Remember the unusually high values and unusually low values, they fall far away in the tails where the critical region is. So if so, then we conclude that our results were unusual, and therefore the null is not true. So that's the logic that we're going to use. Basically, we're going to look at the sample result and we're going to assess if the sample result is unusual. And if it is, then we're going to dismiss the null and say that the assumption that the null statement is true is incorrect. And so what are we going to do? So we compared a p-value against the alpha region, and if the p-value is smaller than the alpha region, the sample statistic is unusual, and we're going to reject the null and accept the alternative. If the p-value is greater than the alpha region, the sample statistic is not unusual, and in this case, we didn't get enough evidence to reject the null. So that's method 1. For method 2, if we're checking if the result falls within the critical region, then this is what we're asking. Did the test statistic fall further from the population parameter than a critical value? If so, then the population parameter is unusual. And again, we reject the null, accept the alternative. And if the test statistic is closer to the population parameter than the critical value, the sample statistic is not unusual, and we didn't get enough evidence to reject the null. So, and that will conclude our test. We're gonna reach our verdict this way. There's one more step though that I haven't mentioned yet, but it's an interpretation of your results. So this is the end of the statistical procedure, but we also have to report back what we found, and that's going to be the interpretation of our results. And that's going to be step number 6 in our flow chart of what to do. So I would compare it probably to reading the verdict out loud. I hope that makes sense.